Let's just do a little bit of basic review here and then get on to learning about factoring as we begin our study of that. And I got done explaining a few minutes ago just how incredibly important factoring is. Spencer!
Yeah.
Would you do me a favor? What day is it, Spencer?
Hump day?
It's Tuesday.
I know it's Tuesday, but it's the Tuesday of the week back from the Christmas break, so that's officially hump day. What day is it, Spencer?
Hump day.
Hump day.
No, it's not.
Spencer, no, it is for this week only. Spencer, what happened to Spencer? You sound like every other kid now.
He fell asleep.
In math? That's
Yeah.
something that's saved for social studies, science.
I fall asleep in social studies all the time. Me and Bacon always fall asleep, and we're in the same row, so it's really funny.
Voice the whole
Sometimes
time.
PMR even falls asleep. Sometimes all three of us are sleeping in the
Everyone
row.
falls asleep. I'm
He
like,
always goes, Sydney's, stop talking. I'm like, what? I literally look at her and he yells at me for talking.
I always tell I'm a crowd. I'm like, wake me up if he like calls like on my name or something.
Did you ever sit in class and you get into that zone between sleep and alert?
And you
And,
hear
and you're
everybody
like, but
talking,
you
it's
hear
just like-
everything the teacher says?
Yeah.
And then they call on you thinking they busted you for falling asleep and you can answer the question? That's the moment
And
of
you're like,
vindication.
you would have thought.
Well, gee there, Mr. Cipriano. I was wondering, how do you feel about that? And then you get there. And so on and so forth. All right. Now,
I fall asleep
hey,
all
what
the time.
happened to the rest of your jacket?
What?
It's like a half a jacket. It's like a baby jacket. Is it gonna grow up and be a big jacket one day? Is it? Spencer, lights please. Okay. It's like all the technology just wants to not work because of the weekend and so on and so forth. Okay, so very first question on the board is a solve for question, which means get the particular variable, in this case b, all by itself. So the first thing I have to do is subtract 3a.
Oh.
Die. 4b. Oh, it has been a long vacation. This is like, woo,
Oh, no, I never knew how to do that.
easy, okay? Divide by 4. Divide by 4. I know. You all slept till noon.
I
1 o'clock.
Just maybe like
I didn't even go to sleep. I spent the entire day. I didn't go to sleep.
Oh, that's not good. I was up at 5:30 this morning. Yes.
How do you know what
Woke up. No.
number you have to do?
M. Atención, por favor. Folks. 4B, well, the word solve tells you what to do, and 4B is the next most important part of it. So you want to get B by itself. So everything, Miss Antos used to say all the time, it runs away from the stinky cheese, and B is the stinky cheese. That's what how she used to teach this. But basically, you're doing inverses and opposites. This is a positive 3B. I look in front to realize it's positive, not behind. Subtract the 3A from both sides, not 3B, I'm sorry, 3A. So 2C minus 3A, and then the B is being multiplied by 4, so I have to do the opposite. Okay? Yes?
Is it okay if you split it up a little bit? Like,
Split it, in other words, C over 2 minus 3 over 4A.
yeah.
Yeah, that's fine. Okay, and in all honesty, you should be able to
Wait, I
see
don't
both.
even know. Yeah.
The 2/4 reduces to 1/2.
So it's a staple.
Okay.
It's like-
What?
Is that supposed to be a 3/4 C, or is that a
Yes.
staple over a 4?
It depends how you tilt your head. Okay, there's a reason why I type everything. Now, find the product. Product means multiply. Negative 10x to the 4th. Okay? And the next one says write a coordinate of a point in the solution set. The point I always look for is 0, 0. It doesn't mean that's the only one you can use. You just want to choose any coordinate in the double shaded area. Listen, stop. This is the kind of question which will appear all the time in where one of the answers they're going to give you is the point of intersection, and another answer is going to be a point on the broken line. You need to clearly understand that if the point is on the broken line, it is not the solution to the problem. It's not in the solution. The broken line means it's not allowed to equal it, all right? It's like this. When you do this graph here, and you do an open circle and arrow too, you're not allowed to equal that circle. You're allowed to come really, really close, but you're not allowed to equal it. Likewise, on the broken line, you can come really, really close to that line, but you can't be on the line. If you're on the line, then it doesn't equal it, okay? Any questions? So pick a point in the deeply double shaded area, and you will get it right. Okay, so, now, come on. There we go. Slope and y-intercept. Well, to do this again, we need to solve for y, because any line to get the slope and y-intercept, we want it in y equals mx plus b form. So I'm going to divide everything by 3. Y equals, is that a satisfactory 3, AJ?
Sure.
There we go, wise guy. All right,
The other
plus
thing was supposed to be a 3?
4. Okay. So, I dare you to write like this and get good 3s. Now, the slope is 2/3, not 2/3 x. The slope never includes the x, it's always what's in front. And the y-intercept is 4. Any questions? All right. So every one of those should be very fundamental, very routine. And now, we ready yet? Now we get to something that's very easy. And no matter what your opinion of factoring, this particular lesson today is very easy. It's called factoring with the greatest common factor. I'm sure you remember the term greatest common factor from when you were younger. Greatest common factor. Factors are things that are smaller, that lead to something bigger, okay? Factors, because they're smaller, divide into a number, as opposed to a multiple, which gets bigger. Like the multiples of 5 are the classic 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, etc. Those are not factors. Factors are numbers that divide into 5, and there's only 1 and 5 because it's a prime number. But if I said what are the factors of 12, there's 1 and 12, 2 and 6, 3 and 4. So factors divide into things. When I look for a common factor, the word common means it's something that belongs to everything involved. In this first question, it's a factor that goes into both. So as I take a look at this first example, what number divides into both 5n and negative 20? Anthony? 5. Now, the answer is 5n, 5 times parentheses, n minus 4. Factoring, a word I love to use to describe it, is anti-distribute. It's distribute done backwards. That's all it is. Factoring is distribute done backwards. Now, factoring is multiplication, so distributing is multiplication. So factoring is going to be division. And that means, yes, we're dividing, but the easiest way to check and see if I factored right is to distribute back and see if I get what I started with. Kyle, head in the game. And as long as you're bringing the biggest common factor, you'll get it right every time. So if I was to multiply back, what's 5 times n? 5n. And what's 5 times negative 4? Negative 20. So you know you got it right. And that, folks, is factoring with a common factor. Try the next one. Now the key is to choose the biggest common factor. There are many common factors on this one. You need to choose the biggest one. Absolutely. We want to go huge.
You know Donald Trump retracted the statement about the wall?
What do you mean?
He said he's not gonna build a wall.
Let's table that and worry about it later.
Yeah, man, today.
No, ma'am. Tuesday. Okay, hey, folks. Okay, so what is the biggest number that divides into both 12g and 24? 12. So I factor out the 12, and I put the parentheses there, and I get g plus 2. Now remember, factoring is what? Anti-distribute. So let's multiply back. 12 times g is? 12g. 12 times 2 is? 24. Very good. Okay, try the next two, numbers 3 and 4. about factoring is, it's not just called factoring in this case, it's called greatest common factor. You have to look for something that goes into every term present. Okay, so what is the biggest number that divides into both 12 and 28? Everybody? 4. So I'm gonna factor out the 4, and that leaves me with 3x plus 7. Now let's distribute back and see if it checks. What's 4 times 3x? 12x, and what's 4 times 7? 28. Please don't be bored, and don't skip over the tedium or the tedious step of distributing back. Because when we factor trinomials, small, when you are able to check yourself by distributing back, you will always know if you're right. And if you put down answers, God bless, without checking yourself, there will be times when you get wrong, when you get the factoring wrong, not because you were incapable of doing it, but because you were sloppy. And we don't want that, obviously. Now, the only difference between number 3 and number 4 is this one has 3 terms. What is the biggest number that divides into all 3? 5. And then it becomes a minus 3b plus 2c, and I distribute back. 5 times a is 5a, 5 times negative 3b is negative 15b, and 5 times 2c is 10c. So those 4 examples are as easy as factoring gets. And there will be times when you're called on to factor literally at that level of difficulty. What makes that so easy is that it only factors a number. But sometimes you have to factor a variable. Not that that's harder. In some ways it's easier because you don't even need to know your times tables. In this particular problem, forget understanding mathematics. If I took a 2-year-old, well, 4-year-old, and said, Johnny, Jamie, what do they both have? What would the little kid say? An A. So the answer to this one is A times A plus 3. Because the common factor, the thing they both have, is the A. Okay? Now, what is the acid test that allows us to know if we factored correctly? What do we always do? Everybody? Distribute back. What's A times A? A squared. What's A times 3? 3A. So Nike has this expression, a marketing campaign, a brand, if you will, just do it.
Don't do it.
Have you ever gotten writer's block?
Nope.
Yeah.
Yep.
Right? Everybody gets writer's block. In fact, I had a friend of mine, they have to do a paper on the Salem witch trials. And I said, listen, I write really well if you need help. And their response to me was exactly what the response should be. It was, all right, look, I don't know much about the Salem witch trials, but if you just give me the first few sentences, I could take it from there. And isn't that the way it works with writer's block?
Yeah.
It's like once you get 2, 3, 4 sentences, now it starts to flow and everything works. It's beginning. It's like sometimes just stare at the question like, and you don't know what to do. Well, in distributing, you can get math block. And you just stare at it. Just do it. Use the Nike expression. Just take your guess. Because as soon as you distribute back, you will see what's wrong. Here's a classic mistake, ready? A lot of kids write that, they pull out the A, and they write either 1 plus 3, and if you had done that, when you do A times 1, would you get A squared? No, and then you'd say, oh, wait a minute, I need an A there, so maybe it's 1A. Or sometimes over here, they'll leave the A here. And then you would do, well, A times 3A is, oh, it's 3A squared, it can't be that. So by trial and error, just by trying it, screwing it up, then in the step of checking back, you see and realize your mistake. That's why I love to call factoring anti-distribute, And whenever you factor, you check, always a quick mental check, that's what I call it, quick mental check. You don't write it on paper, and you just check and see if it distributes back. If you do, you know you got it right. Try number 6, and then try number 7. AJ, spasms?
Yeah.
All right, so I think number 6 is pretty easy and straightforward. What's the correct answer to number 6?
7.
It's not 7, I promise you. A, what?
8 times A minus 7.
Good. Now, always check ourselves back by distributing back. A times A is? A squared. And A times negative 7 is? Negative 7A. Okay, now number 7 is the next level. And this is the highest level when it comes to common factors. Factoring with the greatest common factor. Because now, not only are we going to find a letter that they share in common, but we're also going to find a number that they share in common. And what you should simply do is, listen, were the first ones in blue very hard? No. Were the ones in green very hard? No, a little bit of an adjustment, but not that hard. Well, now you're going to take the thought process, girls, AJ, the thought process that you used for blue and the thought process that you used for green and do them simultaneously. Number 7, they share a 5 in common and they share an A in common. So I'm going to factor out a 5 and an A, and that leaves me with an A plus 3. Now, let's check by distributing back. Ready? 5A times A is? 5A squared. 5A times 3 is? 15A. You know, on Friday we had a Math 8 test. And I got a kick out of a note that one of the kids wrote me. I haven't graded that paper yet, but it was pretty funny because it reminded me of me. When I was a kid and I did a test, as long as there was time at the end of the class, I would go through and count all the questions I knew I got right. And then I would add up those points. And someone would say, how did you do it? I go, well, I know I got at least a 92. Well, they'd say, how do you know that? I said, because I checked these and I know they're right. Now, if I got the other ones right too, I might have a 96 or a 100. Well, hey, don't pack up. When I look here, the beauty of factoring is you can always distribute back and you know if you got it right. So when I give you these questions on a test, before you ever hand that test in, you know if you're right or wrong. Try the next one. We have about 4 minutes left, so you're a long, long ways from packing up. Okay, so what do they share in common? Do you know? 5 and an X, very good. So let's pull out the 5 and the X. And what I'm left with, how many times does 5 go into 10? 2. Now, if I factor out, or I pull out one of those X squareds, what remains? An X. Now, negative 25 divided by 5, or factored out, leaves negative 5. And I already pulled out or factored out that X. So I'm not going to just assume I'm right, because you know what Papa taught me about assuming, right? When you assume,
Oh, I know.
you make an you-know-what out of you and me.
My dad used to say that.
Yes, so we want to be careful with that, okay? Now, 5x times 2x is indeed 10x squared, and 5x times negative 5 is negative 25x. And by the way, I just want to mention that this shows that when I make do-its, there's often things in the do-its that have to do with, if you understand that, you'll understand the lesson. So I think it was the second question, which was a multiply two monomials question, and now here we have in factoring, we're constantly multiplying and checking ourselves with monomials. Okay, try number 9. What do they share in common? Everybody? Not a V, there's no V in the last term.
Oh, wait.
That one, 'cause I
But they
don't
share a
know.
3. So it's V squared minus 3V minus 7. Multiply it back, it will check. I want to jump forward to number 11 before we end class today. What does number 11 share in common? First, the number. What number? Everybody? No, number 11, not 10.
I think 2.
All right. Actually, they do share a 2, but there's a bigger
Four.
number, 4. We always want the greatest common factor. But here's the slight little twist. What's the largest number of n's that they share in common? Everybody?
And
Squared.
squared.
N squared, very good. So that leaves me with 2n cubed plus 5n minus 8. And let's distribute back to check. 4n squared times 2n cubed is 8n to the 5th. That is 20n to the 3rd, and that is minus 32n. Hasta la vista, vaya con Dios, toodaloo, ta-ta. Arrivederci, smile a lot, ciao, arrivederci, adios amigos y amigas, cheerio, garushus, kadafis, enjoy.
Kiara to room 205, please. Kiara to room 205.
Shalom.
I know.
188.
Wait, your cross reports were handed out. I did the retest, right?
Oh, yeah, I think so. Not 100% positive, but I believe